Okay, welcome back. In this applet, we compare similar triangles. So you're to do an investigation by controlling these, by adjusting the control points. So what we can notice is there are two similar right-angled triangles being set up. One is a normalized one, a kind of a particularly scaled one, so the hypotenuse, or later the adjacent, is one, but for sine and cosine, the hypotenuse is one. With any right angle triangle with the sides varying as we wish. The only restriction is that it's a right angle triangle. And we can change the angle around as I'm doing here. Okay, so let's continue our investigation now. And let's investigate sine first of all. So in terms of ratios, the definition of the sine ratio in a right angle triangle, so in this case, the definition of the sine of 26.6 degrees is 4 over 8.944. And that calculation is done for us here. I get 0.447. But look at what happens, and look at our interpretation when we look at it in terms of the normalized triangle, which is constructed using what's called a unit circle, because the circle here, which you could draw with a compass on grid paper, has a radius of 1. So any of this, the variable point on the circle, can create a triangle by dropping a horizontal line segment and then considering the vertical line segment. The vertical, sorry, I got those words wrong. Vertical line segment here and a horizontal line segment here. And so, you see, what's interesting here is we have taken out the need to divide by the hypotenuse when the hypotenuse is 1. Because think about it, dividing by 1 doesn't change the answer. So opposite of 0.447 is the sine of 26.6 degrees. I mean, now we'll bounce it back over to this one and say, so what sine really means is the height of this, if you use the hypotenuse as your measuring gauge, your yardstick, so to speak. So how many 8.944s fit on this green line segment? The answer is 0.477 of them. Okay, let's just change the hypotenuse around to 3.204. How many 3.606s fit on this? 0.555, but that is the sine. Okay, and you have similar situation for cosine. How many 5.831s fit along here? Of course, it's going to be a number less than 1. It's 0.514. Okay, and notice as we make the angle smaller, we actually see more, even if it's a fraction, more 6.083s fit here, 0.986 of them. So the interpretation of the cos, or the cosine of 9.5, is how many hypotenuse fit on the adjacent. Recap on sine. What's the meaning of the sine of 9.5? How many 6.083s fit on the opposite? That's leaving tan. So a slightly different picture here, in that the line segment we draw on the unit circle is from the outside rather than the inside of the circle, from the end of the circle. So here our restriction is that 1 is the adjacent. So the interpretation of the tan is, of course, 3 divided by 6, or how many 6's fit in 3? How many adjacents fit on the opposite? That's what tan means. How many adjacents fit on the opposite? How many 7's fit in 8? 1.143. How many 7's fit in 2? 0.286. That's what the tan of 15.9 degrees means. I hope that has improved your understanding of tan and sine and cosine, and given you a way to kind of put some physical meaning to sine, cos, and tan, whether that be the unit circle or whether it be using a different unit of measurement over here on any given right triangle. Thank you.